Okay, in this video, we're going to talk about how to use then all these sum and difference formulas to actually solve for x, and that's the idea. Okay, we want to be able to solve an expression that looks like this, and it looks terrible, doesn't it? It looks like I have a sine graph that's been shifted left pi over 4 spots. I'm going to add it to a sine graph that's been shifted right pi over 4 spots, and I want to find out where those two together, when I add those y coordinates together, where do they add up to -1? Of course, you could always use your calculator, right? You could use your calculator and type this in exactly like you see it. Y1 would be the left side. Y2 would be the right side. You find out where they intersect. And when I graph it, I would make sure my calculator is in radians, and I would make sure my window went from 0 to 2 pi for the x coordinates. And I would want to make sure the y coordinates included -1. So maybe I go like -4 to 4, right? So you can always graph this to find the solution. And hopefully you end up with nice, neat numbers. But the problem is we want to be able to work by hand. So we're going to take it one step at a time. If I do this, I see, just cover up this, I'm going to look at this first section, I see that sine of u plus v, right? This is the sine of u plus v. So I can go through and I can use the sum and different formulas. In fact, you know what, before we go any further, you notice how those are the same u and v? Well, that's pretty convenient, isn't it? So we only really need to do a couple of triangles here maybe, or whatever we're doing. It looks like I have these two formulas that I'm going to combine together, right? So I'm going to say this is the sine of u plus v, there's the first chunk right here, plus the sine of u minus v. That's the second chunk over here. Looking at this, if I expand this outward, it looks like it's the sine of u times the cosine of v. So I'm talking about the sine u plus v. Right? I'm doing this section first. That is the sine of x times the cosine of pi over 4. I'm going to add to that the cosine of x times the sine of pi over 4. There's my first chunk, right? Now I'm going to go to the second chunk, and it looks like I'm going to run out of room with this other problem here. I needed more left to right space. So I'm going to go and write right below it, okay? Sine of u minus v is sine u cosine v, which is sine x cosine pi over 4. And then this time it's minus cosine x sine of pi over 4. Whoops, I didn't need the parentheses there. So ignore this little bracket that I have in the middle. That was a mistake. All right. So there's my second chunk, right? Now I just need to combine all these, and I want to make them as simple as possible. All right, well, the first thing I know is that pi over 4 is 45 degrees. The sine and the cosine of 45 degrees is 1 over the square root of 2. So I really have then that I have 1 over the square root of 2 times the sine of x plus 1 over the square root of 2 times the cosine of x as the first and second terms, plus 1 over 2 square root of 2 times the sine of x, and then minus 1 over the square root of 2 times the cosine of x. Whoops. 1 over the square root of 2 times the cosine of x. And remember, I'm trying to find in all of this where is it equal to -1. Well, the nice thing is you might notice that the cosines completely go away, don't they? And so I'm left with 1 over the square root of 2 plus 1 over the square root of 2, which is 2 over the square root of 2. Sine of x is equal to -1 now. Well, that's not too bad then. It looks like I need to divide both sides by this 2 over the square root of 2, or I can multiply both sides by the square root of 2 over 2. That makes these go away completely, and I have sine of x is equal to negative square root of 2 over 2. So all of that, after all this, so for a while, look, we got to make it longer. But when we make it longer, stuff goes away and it simplifies down in a hurry, right? So don't be afraid of this. Don't be afraid of this step. Well, if the sign is negative, that tells me that it's in either the third or the fourth quadrant. And if I remember right, then I know the square root of 2 over 2 is the same thing as, really, that's 1 over the square root of 2, right? -1 over square root of 2. So I know opposite is 1, square root of 2 is the hypotenuse. That's a 45-degree angle. That's nice because now I can figure out the overall angle. This would be 180 plus 45, that's 225 degrees. And this one over here is 315 degrees. So my last step is, because the answer needs to be in radians between 0 and 2 pi, I just need to convert these. It turns out that my two answers are 225 is 5 pi over 4, and 315 is 7 pi over 4. Well, I did not give you enough space to work that problem, did I? Alright, let's go do another one. Let's make it quick. I'm going to go faster in this one. Same idea. We got to break it up. We got to make it a little bit bigger this time. But we're going to see if things simplify in a hurry. Sine of u plus v. I look at my formula sheet and I say, all right, u is x and v is pi over 2. Here's u and here's v, and I'm going to have a different u and v over here, aren't I? Because now I got pi over 2 and 3 pi over 2 over here. So I'm going to have to do this. It's going to take a little bit more work, but not much. Not much. Okay. Sine of u plus v is going to be sine u cosine v, sine x cosine pi over 2, plus cosine u sine v, cosine x sine of pi over 2. There's the first chunk. I'm going to add, and now I need to do the second chunk. This is u minus v, so I need to use the bottom formula. This is going to be sine x cosine of 3 pi over 2 now, minus cosine x sine of 3 pi over 2. I use my calculator to figure out all the values that include like the pi over 2s and stuff like that. See, I know that this is 90 degrees, and if you do the cosine of 90 degrees on your calculator, you find out that that is 0. Well, if that's 0, that means you have sine times 0. This whole thing goes away, doesn't it? Over here, if I put sine of 90 degrees or sine of pi over 2 in my calculator, I find out that that's 1. And since that's 1, that means I'm just left with cosine x. Over here, I do the cosine of 3 pi over 2, and when I put that in my calculator, I find out that's 0. That means it's 0 times x, and it goes away. That means I'm left with the sine of 3 pi over 2, which, by the way, is negative 1. So I have minus a negative cosine x. And remember, I'm trying to figure out in all of this, where is it equal to 1, right? Notice the double negative. Minus, and this is negative as well. So what I end up with is the cosine of x plus the cosine of x is equal to 1. That's 2 cosine x is equal to 1. Therefore, cosine of x is equal to 1/2. Cosine is positive in the first and fourth quadrants. I know the adjacent is 1 and the hypotenuse is 2. That means the third side is the square root of 3. We know this triangle. We've done it 1,000 times. That's a 60-degree angle. So my two solutions are 60 degrees and 300 degrees. But that's not good enough. We need to put it in radians. That means 60 is going to be pi over 3. 6 times 5 gives me 30. So 60 times 5 is 300. So 5 times pi over 3 is the same thing as 300 degrees. And now we have our two solutions between 0 and 2 pi.